This morning's first giveaway prize is a lock-picking set in the form of a little metal card that is small and heavy and pointy. So I'm not chucking it at anybody. I'm going to chuck my business card, and whoever's lucky enough to grab that can come get me to get the lock-pick set. Sorry. First talk up is Chema and Palico are going to talk to us about being blind drunk last night. I mean, blind SQL injection.
Good morning, everybody. Thank you for coming this session. First of all, let me introduce myself a little. I work in a company called Informatica 64. It's a Spain company. I'm from Spain. And I'm also a Microsoft MVP. MVPs don't work for Microsoft. It's just an award. Some people said we are most valuable pets, but it's not true. We are most valuable professionals, more or less. And with me, is Palaco. Palaco is almost working for Microsoft in Yahoo, and he's working at Mobility. Both we are from Spain, and if sometime in your life you meet with someone from Spain, please don't ask for the bullfighters. Well, in Spain, there are a lot of things you probably may talk about, so don't ask for bullfighters because not everybody likes bullfighters. Well, the session for today is about SQL injection. SQL injection is an old friend. It's been more than 10 years since the first word about SQL injection attacks. This was the first document we have. The first document published about SQL injection is from Rainforest Puppy, and it was published 25th of December in 1998. But this vulnerability is still a good topic in web security. Today, we are going to analyze 4 points about blind SQL injection attacks and SQL injection attacks. First one is about how it's possible to extract a lot amount of data in only one field in a web application. And the second one is possible to construct a binary logic using mathematical operations. The third one is about if it's possible to download files from the server where the database is running using blind SQL injection attacks. And the last one is about it's possible to construct a binary logic with based on time delays in environments where there are not time delays function. Well, let's start for the beginning. Palaco.
So let's get started with the first topic. We are definitely assuming that everybody here knows what is SQL injection and who is Bobby tables and all that stuff. Okay. In this case, what we want to take advantage here, or basically the problem that we want to solve is that sometimes what you want is a lot of information for the database. You basically want to download the whole database or lots of tables, lots of different fields and that stuff. And there are some scenarios where this is possible very easily. Like, for example, say that you have a page in which you can have a list of all the news corresponding to a category. Then you can perform this simple union, select the fields that you want from the table that you want, and then because the page is going to render all the rows in the table to see the news in the category and the stuff, you're basically appending one row for each of the records that is in your query, which is fine. It's a very fast way of extracting data for the database. Not always you have such an opportunity, and most of the times what you have is maybe the injection is just in the page that renders the article or whatever thing that is making a query to the database that is expecting just one row set, one record set, one row from the database. If you're trying to inject here something like union select star from wherever, and then the result will be more than one row, this will not work. So the way to go around this is like select top one from or select limit one from, depending on the database you are, and then you get the first record. Then you have to make a second query saying and whatever not equals this other thing to get to the second record, and so on. When you have thousands of records, this means thousands of queries. And then you can have IDS systems or HTTP firewalls and things like that detecting this behavior and therefore blocking you. What we came here is with a technique to, with just one single query or just very, very few queries, get as much information from the database as possible. So we've been doing this for the three most common database engines, SQL Server, MySQL, and Oracle. And the fantastic part of it is how easy it was for some of them because it was already supported without us knowing it. In the case of SQL Server, there is a very nice function from SQL Server 2005 that is called for XML, which basically allows you to take any single query that you want and then specify that you want the results in XML. That is, I guess, the purpose of this is the very easy integration with all the .NET development environments. So you basically can put together a table to represent data with the table from the database that you want, and then get XML in the middle, that stuff. So it's very easy to do this from a developer point of view, and now for a hacker point of view, it's very easy to take advantage from this. So basically what we're going to do is the same technique that we've been using for years, like inserting subqueries in the select fields of our injection, but now in our subquery, and only in our subquery, we want to specify that that particular subquery, we want it in XML. What this is going to allow us is to work with a string. It's not anymore a record set of several rows, it's just a string in XML, and then we can parse the string to separate the rows. But from the database point of view, it's just a field. A couple of tricks here is that we don't just want text-based files. We might want images or password fields that might be binary encoded and stuff. So we have the appropriate options for doing that. When it comes to MySQL, it's not that easy. There's a way of doing this with XML and MySQL, but it's not supported by default. There is some third-party extension that you need to have on the server, and it's not a very popular extension. So when you're attacking a MySQL database, you cannot really expect to find that extension loaded. However, from version 4.1, we have something called group concat. And group concat, what it's going to do is basically is going to concatenate the results from different rows in one single row. So if you see here the example, oops. As you can see here in the example, there is some XML here, but that is not intrinsic to the MySQL way of exploiting this. It's just because when we create our tools to make this, we want to make it as similar as possible. So we are converting with this query using group concat to something that uses XML tags, and then we parse the response from MySQL the same way that we parse the response from Oracle or SQL Server. So there are some tricks here because there is no unlimited amount of data that you can load from the database. There is some limits in these functions, but of course there's always workarounds to that. And techniques in Oracle is basically the same. It's a different set of functions, but the technique is the same. Something to remark is that in MySQL and Oracle there is no star support, so you cannot inject something like select a star from whatever table and then transfer to XML, because in the XML transformation function, a star is not allowed. And then you need the information schema tables and that stuff to go for the data. So let's see this working. So what we have here is a demo application that we made for the con. We can exploit this, as you can see here, in the 3 database engine. We're just going to perform the demo in one of them. The application is a very typical application in which you can see record sets from the database. So each one of these tabs here would correspond to a record set in the database. And then the kind of injection that you would do here is like, I guess everybody is familiar with this. Union, select 1, 2, 3, 4, I'm assuming that everybody is familiar with this thing here. Okay, so you can see here how we display the data. Okay, just what the data that we inject. If we want something a bit better, so for example, I'm going to choose the number 4, which is displayed on the screen, and then I'm going to substitute this with some select top 1 from select top 1 name from sys users.
Sí, user de falta.
Users.
Oh. Me dejas que no borrar, vuelvo a ponerlo. Quitando.
Select top 1 name from sys users. Some stupid thing going on here.
Don't forget, try it with.
Well, anyway, this is the way where you usually insert something. I probably have a typo that I cannot see with the demo effect, of course. So the thing is that if I were trying to do here something like select a star, so the way to do is I do select top 1, and then I get the first result, and then I do something like I would get DBO, and then I do select the second row set with maybe select top 2 or select word user not equals to DBO or things like that. So.
Put one input to the union.
Yeah, sure, absolutely.
The space.
Yeah.
You need a comment on the end. A comment.
The comment.
Whoop.
No.
There's probably some typo here, but yes, very basic injection. So what we want to achieve here is some query like select.
Start from the beginning. Schema, and then union here.
No, but it's not a union. Union select.
2, 3, 4. Okay, and then change.
And then I change the 4.
Take it easy.
Select
top 1.
top 1 name. Users. Anyway, doesn't matter.
Type's got to match. That type on that.
We usually inject it on the 3.
No, in the 4. No, it's okay. It's in the 4. I don't know. What's
Anyway,
your type? Try
that's
the
fine.
right one.
This one.
Well, that's the old way, so don't worry. Try the new one.
Yeah, exactly. So basically what we want to do with the tool here is something like select. I want all the records from the table, okay, from sys users. And then I want to specify like this, it will fail because there are several records here. So what I do is for XML row, and then binary base 64, because there are some passwords in binary form in that data, in that table. So I don't know if there's still there. So here we go. I don't know how the other is not working. So basically what we have here is you have the 1 and the 3 there. You cannot see the 4 because it's embedded in XML tags. But if you go to the source code, you can see here at the very end, like all the rows from the database. I'm going to highlight one of the rows, okay? So this is all the data from the information. So this is one row. This would be the only thing that I could achieve with the normal techniques, but you can see many other rows below and above this, and I got all of this with one single query. So what we did is we automated this in a tool, and then in this tool, basically what I'm doing here is specifying the database engine that I want. The tool supports also Oracle and MySQL. That is the URL that I'm going to exploit. This is the injection pattern here. So basically, I'm just saying with this 0 here where I want the injection. This is the injectable parameter. And then I just initialize the query, get the schema, and here we go. This is the schema. If you go to the debug log, you can see that it's one single query to get the whole schema of the database. If now I want to go for the data, no matter how many rows or records are in these tables, I just can retrieve all the data with one single query again. Same for the other table. Okay.
You have to pay the lunch because your first demo wasn't working.
That's because I'm using a Windows inside a Windows.
Exactly. Well, the second point of the agenda is about arithmetic blind SQL injection. In blind environments, the attacker cannot access directly to the data. This is just because the web application doesn't show any data in error messages, or because the web application doesn't print any data retrieve. So we have to perform a blind attack. In this environment, we have to inject certain types of queries to change the behavior of the web application and to extract the data. The goal is to construct a binary logic to recognize a behavior as a true and a behavior as a false. So the easiest way to do this is just injecting something like 1 equals to 1 or 1 equals and 1 equals to 2. If the web application behaves in different way, in one way and another, we are going to be able to extract all the data from the database. To do this, we can use different characteristics. In 2004, Cameron Hodgkin delivered a very nice presentation in Black Hat, and he analyzed the different behaviors you can use to construct the binary logic. The problem, well, this is the normal way in blind SQL injection attacks. As you can see in all the examples, we can extract all the data from the databases, just comparing ASCII value of the letter we are searching for with numbers. This is in MySQL, Microsoft SQL Server, and Oracle. The problem is what happened with those environments in which the vulnerable parameter is in a mathematical function. In these environments, we cannot inject logical operators, and we have to construct a binary logic just using mathematical operations. First method is dividing by 0. This method was described by David Litchfield 10 ago. And the idea is to get the denominator to 0 when the condition is true in true answer pages. This will only happen with the ASCII value of the letter we are searching for is equal to the counter. So this will mean a true, and otherwise will be a false. The second method is just to use the normal response page, the non-injected response page, as a true. So we are going to add the ASCII value of the letter we are guessing, and we are going to subtract the value of the counter. When we obtain the same response page, this will mean a true answer page. And the last one is to overflow the data type. And in this environment, we are going to use this division, and this division will be only true when the counter matches with the ASCII value of the letter we are guessing. When the division becomes 1, then we are going to add a constant that overflows the data type. So let's see this in our testing environment quickly. So in this case, we got an application, and this application uses only this parameter, and this parameter is in a mathematical function. So if we try to perform a normal blind SQL injection, 1 equals to 1, we retrieve an error message because it's not a numeric in the parameter. So let's try this. First one, dividing by 0. In this example, we are going to use as denominator this, the ASCII value of the letter we are searching for, and minus 99. In this example, we are searching for the first letter of the first user in the 6 user tables, and this is the D, and the ASCII value of the D is 100. So in this case, it's not 0. So what we are going to obtain is not an error. So let's try this. Okay, we retrieve the same record. So we don't have an error message, but if we change this to 100, which is the ASCII value of the letter we're searching for, we are going to obtain an error. Okay. Second way. In this case, we are going to add the ASCII value. In this case, we are subtracting, but it's the same. The ASCII value of the letter we're searching for, and we are trying to compare with 99. In this example, we are going to obtain a different page than the normal page. So first of all, let's try with the normal page without any injection. With the normal page. And we are going to copy from here to here. Perfect. Then try it, and we retrieve a record. In this case, this will be the normal page, the non-injected page. So let's try with any value. In this case, we are trying with 99, which is false. So we have to obtain other response pages. But if we change to 100, we are going to obtain the same page. So it means that the ASCII value of the letter we're searching for is the 99, is 100. And the last one is try to overflow the data type. In this example, we got this constant, a big number multiplied by 333, and this number will be only add to the parameter if this condition is true. I mean, if 99 divided by the ASCII value of the letter we are searching for are equal. So in this case, it's false because our value is 100. So we obtain a record. And if we change to 100, then this will overflow the data type, and we obtain a true answer page, in this case, the error message page. So let's go with the third part.
Well, you've seen how we've been very quick at the beginning with how is or how what is a blind SQL injection vulnerability. We are kind of assuming that everybody is familiar with that. And then we just saw one more technique to see if the application is vulnerable. And we've been getting the first character here of the password, of the user. You know how to get for the second character of the user and the third character of the user and the stuff. So assuming that everybody knows how to get all the information that this user has permissions for in the database, what else can we do if we know that we have a blind SQL injection vulnerability and we want something else that is not in the database, like, for example, accessing a file? So what we are doing here with this technique is using blind SQL techniques to access contents of files in the server. The way of doing this is basically what we want to do is somehow load the contents of the file into the database manager and then convert that file, the contents of that file, to a string. And then, same as we just did, we will go for the very first character of this string, then we will go for the second character of the string. Just a quick reminder, the way you do this is either you do bitwise operations or you do some kind of binary search, and then you have a maximum of 8 queries per character which would be an average of 4 or 5 queries to guess each character. When it comes to files, that means that you need this lot amount of queries per byte on the file. So as you can see here in the slide, basically some way transform the file to a string and then query a string as in any other BlindSQL injection application. There's usually 2 ways of doing this in Database Manager. One way is creating some kind of temporal table based on the contents of the file. The other way is to load the contents of the file in memory to be used within the query in every single query. So for SQL Server 2000, there was 2 ways of doing this. A quick and easy way was using built-in drivers. You cannot access any kind of data, any kind of file type with this technique, because you can only access the files that are supported by the drivers. But then if that is what you're looking for, it's very easy, because with just this single query here, you basically you basically load the contents of the file to query those with a select statement, as you would do with any other table. If you want a different type of files, it's just slightly more complicated, because you need 2 or 3 different statements to do this that you have in the slide. And basically what you're doing here is creating a temporal table with the content of the slide, of the file, sorry. You tell the database where is the file, how are you going to separate the fields and the rows and the stuff, and then again access the contents of that table that you just created using standard BlindSQL injection techniques. Don't forget to clean up, dropping the table that you created. Sometimes the user that is the user that the web application is the user that is accessing the database from the web application doesn't have the permissions to create temporal tables, which is not a problem anymore since SQL Server 2005, because we have now these super nice features that allow us to load in memory in every single query the contents of any file in the system, as long as the user has permissions to get for that. And then this is actually very, very heavy for the server, because you are loading the whole file in memory. You're not using drivers here anymore. You're not creating temporal tables anymore. So in every single query, you're loading the contents of the file in memory and then accessing them. So keep in mind that you might be wanting very big files, like images, like 3 megs of images or 5 megs of images, and then because you're using BlindSQL injection techniques, and as we said, you might need as many as 8 different queries per byte. This is a lot of queries, and then this is a lot of megs in memory. So this is very bad for the engine, very good for the hacker. So techniques in MySQL and Oracle, we put them here in the presentation just for you to have the record, but it's basically based on the same. Creating temporal tables here in the case of MySQL database. There's tools that have been doing this for more than a year now, and then this is the way you do it in Oracle with plain text files, creating virtual objects that map to physical paths on the server, and then basically you tell how do you want to identify different rows that will be records in the table, and how you want to identify different fields that will be columns in the records. Or you can use the built-in DBMS for large object files, large objects in Oracle, and then this way you can also access binary files. So again, let's do this. I mean, this is very, very tedious when you have to do this manually, so we created tools for automating all this stuff. This is again a demo application. You can see how we have the 4 different engines that we support here. We're going to try with one of them, is SQL Server 2005. Okay, and then and 1 equals 1. That's fine. And 1 equals 2, that's not fine. So vulnerable to SQL, BlindSQL injection. Then we go to our tool. And then in this tool, what we have here is That is the URL that I want to attack. That is the file in the server that I want to extract. That is an injectable parameter that I want to use. That is a keyword that I want to recognize in the test to be able to discern between true and false answers. And then down here I have where do I want to store this in my disk. So we have support for SQL Server also, both versions of SQL Server in the tool. We have support for Oracle. You can specify what kind of file are you trying to access, either text files or binary files, support for MySQL, and then we have the log here. So assuming that everything is set up, we just start this. And if we go to the log, here you can see how it's making like 5, 6, up to 8 different queries per character that I want. Okay. Here in the left part, you can see how I'm trying to guess the values with a binary search. And this is going to take a while. Like, depending on the size of the file that you want to access, it's going to take a while. We can go here. I was trying to store the sum here. So I'm assuming that everybody has seen a sum file before. And you can recognize here the beginning of the sum. Let's keep this running on the background and then go back in a while to see how it goes. Okay. So,
well, let's go with the last point of the agenda. Well, now, in this part of the agenda, we are going to try to answer the question about if it's possible to perform a blind SQL injection, a time-based blind SQL injection in those environments in which it's not possible to use time delay functions. In scenarios where there are no difference between the true answer page and the false answer page, a time delay blind SQL injection can be performed. The idea is to inject a time delay in the true answer pages. To do this, in several databases, we have a special function to stop the response. In Microsoft SQL Server, we have the wait for function, and Chris Hanley in 2002 described how it's possible to use this function to stop the true answer. And as you can see in the example, write down how it's possible to stop the response of the database if the condition is true. So in this case, the only thing that we have to do is measuring the time, and if the time is 5 seconds, this means that the table exceeds and we have access to it. In other database engine, we got other function. For instance, in Oracle, we got the DBMS log package, and in it we have the sleep function. The problem with this function is that it's necessary to inject into a PL SQL block, and it's not quite common to find this in web application. In MySQL, in version 5 or higher, there is the sleep function, and in version 4, we got the benchmark function. Benchmark is not a time delay function, it's a long time consuming function, and we can measure in time with this function. For instance, this is a real example. It's an exploit that was published in 2007. It was for a game. Some people don't like to lose the games. And in it, the attacker performed a time-based blind SQL injection attack. In red color, you can see how the time is measured. And in blue, you can see the injection. The injection is quite funny because it's in the user agent HTTP header. And in it, he is injecting something like, well, fuck you is. And the injection takes place in the insert, not in the select. And here, as you can see, he is using the benchmark function to force a more than 7 seconds time delay. At the end, if the response time is greater than 7, it means that this value is part of the password. Op. Well, last August in 2008, Ferrut published a new method to perform time-based blind SQL injection attacks. It was called Deep Blind SQL Injection Attack, and in it he used different time delays depending on the ASCII value of the letter we are searching for. It means if the letter is an A, the response time will be 10 seconds, or if the letter is a B, the response time will be 11 seconds, and so on. To do this, he forced different time delay in the wait for function. Okay. And the question is, and what happened in those environments in which we don't have time delay function, we don't have access to the delay function, for instance in Microsoft Access databases or DB2 or environments like Oracle without the possibility of injecting in the PL/SQL block. Can we still perform an exploitation of time-based blind SQL injection attack? Of course, yes, we can. I always wanted to say this. Well, I always wanted to say this. You can imagine me in the White House. Oh, well, let's analyze how the query is executed in the database engine. Let's suppose this query with more than one condition, in this example with condition 1 and condition 2. And in it, the condition 1 takes 10 seconds to be evaluated by the database engine. Condition 2 takes 100 seconds. The question is, which condition should be executed first? Well, if the heavy condition is executed first, then we are going to obtain more than 100 response time in all the cases. So, as you can imagine, this is a bad decision for tuning. So the idea and what the database engines prefer is to evaluate first the light condition. In this example, we are going to evaluate only the heavy condition when the light condition is true. So we are going to obtain a very short response time when the light condition is false and a big response time with the light condition is true. So knowing this, we can perform a time-based blind SQL injection attack taking advantage of this. The idea is to evaluate only the heavy query when the condition is true. So we have to take into consideration that there are two types of database engines. One of them with optimization process, so you don't have to worry about where to set up the heavy condition and the light condition, but others haven't optimization process, so you have to know the default rule. So some of them evaluate from right to left and others from left to right. You have to know this in order to set up the heavy and the light condition. Well, the trick to construct a heavy query is just to join a table itself as many times as you need. For instance, a table with 4 records and 2 columns, joining itself 10 times generates more than 1 million of records. So it's a big amount of data. So in this example, as you can see here, we are joining the sys user table with itself 8 times, and we are comparing with, and we are using as a light condition the comparison about the first letter of the first user with 300. As you can imagine, this is true because all of you know that ASCII is only until 2055. Oh? You know it. Well, which table you can use to do this? Well, the normal tables. In any of the tables in the dictionary can be used. In Microsoft SQL Server, sys users, sys columns, sys object, sys databases. In Oracle, all of the tables in the dictionary, all users, all views, whatever. In MySQL 5, you can use the tables in the dictionary also. And in Microsoft Access databases, you can use one of them. MSys Access Objects in versions 97 and 2000, and MSys Access Storage in versions 2003 and 2007. And if not, you don't have access to these tables, or you don't have a dictionary, well, I suppose you can imagine the name of usual suspects. Clients, customer, news, login, users, provider, or whatever. You only have to know or to guess the name of a table with some records, and you can extract all the data from the database doing this. Well, in this example, we are using a wget command, and the most important here is the time measuring. As you can see, we are injecting a heavy query with 6 users in a Microsoft SQL Server and a like condition. In this case, this is true because the ASCII value of the letter we are searching for is lower than 300, and the query starts at 23:49:11 and ends 14 seconds after. So this means a true. If we change the condition to with a like condition false, in this case comparing against 0, we obtain different time response time. It means it starts at 28 and it ends at 29. So it means a false answer. We can do the same in Oracle. This is with the true condition. It starts at 55 and ends a lot of time after, 22 seconds. False, if we change, we obtain only 1 second. The same in Access 2000, the same in Access 2007, and so on. As you can imagine, this is a tough task to do it manually, so we developed a tool. This tool is available in CodePlex. This tool is called Marathon Tool, and it's ready to work with Microsoft SQL Server databases, with MySQL, with Microsoft Access, and with Oracle databases. Is available also the source code, and is developed in .NET. So let's see this in action. And before I start this demo, let's see. Palaco's demo, your demo? Ah, okay. Well, Palaco let the SAM file downloading. As you can see, we got 679 characters of the database, and the SAM file is, well, for sure you recognize this file. So let's stop this, and let's go with the last demo. In this example, we got a vulnerable web application, but this application always returns the same page. So if we inject something always true, 1 equals to 1, we obtain this record. And if we inject 1 equals to 2, we obtain the same record. This happens sometimes just because the injected parameter is giving us the default value. So if the developer, if the query doesn't return any value, then give us the default value. And also this is quite common in forms where when the developer is going to insert in the database whatever you type in the form. So let's try with Marathon Tool an attack. In this example, you can see we are going to inject in SQL Server 2005, but this tool works with all of these versions. And we have to set up the vulnerable URL, the vulnerable parameter, and of course the time settings. In this case, we are going to consider a heavy query if the response page give us more than 1 second in response time. This is just because we are working in the local machine, but if we are working across the internet, this time should be higher, maybe 5 seconds or so on. And this is the tables that the tool is going to test as in order to construct the heavy query. But you can type whatever you think is a good table. So let's initialize. Let's start. And now we can try to get the user. So if we have a look to the log, we can see what the tool is doing. In this example, see the tool is trying to construct a heavy query with 3 joins, and it didn't work. So try with 4, with 5 tables, with 6 tables, with 7 tables, and at the end, when the application, when the tool find a heavy query, then start to find out the length of the username. So you can see the log in this format, but you can see it also with the whole query, and you can see what the tool is doing. At the end of this process, we are going to find out the value. We got the length of the username is 2, and of course this is the most famous user in Microsoft SQL Server databases, you know. And let's change it to 90, and you can see here we got the S, and we need to find the A. We did it, okay? Of course, if you want to download the whole schema, you need to take your time, of course. At the end, with these 4 points, none of them are silver bullets, but all of them are new bullets in your pocket. And of course, these techniques only success if you forget Bobby tables. If you don't forget Bobby tables, you never have to worry about this. And that's all. ¿Alguna pregunta? Here.
We've had web application firewalls, for a decade or more with kind of mod security. When are we going to see database application firewalls become more common?
How could I know the answer to that?
Anybody really developing one?
Not that I know.
Don't know.
Not that I know.
What?
Well, there's lots of products that are doing, that are looking for anomalous behavior, overly queries, time-based queries, and trying to prevent non-traditional data. You're supposed to get 1 credit card entry, not 5,000 credit card entries, that type of thing. So there's a series of products that make Perla is one, and there's begin with the PDF campaign.
Yeah, I guess it's very difficult to establish default rules that are valid for every application.
That's the problem. They have to learn. And most people, like IPS, they don't turn on the block. They just, after the fact, they want stuff to block the door.
There is a database application firewall free SQL for MySQL. It's free and it's on source code.
Okay. Okay. Good to know.
Do you have any plans to add Postgres support?
Can you repeat, please?
Are you planning to add Postgres support to your tool? I noticed you had one Postgres example, but
No, all the tools are just proof of concept. You have the source code. Our job is not delivering hacking tools. It's just
do you think Postgres was useless, or do you think it was harder to do BlindSQL along with the other databases, or just you didn't get around to implementing that?
yeah, no.
So most of these techniques are valid for Postgres too. So you can extend the tools if you want. And I have Cocoa for Mac version of some of these tools, and also kind of hacker black screen with green letters tools of it. So if you write me and prove that you're not a kitty, then you can get those too.
Last year, one of the security magazines had an article on SQL injection detection evasion, which gave a language-based examples of how to beat SQL injection detection
Gracias. Cambiando los comentarios.
No, not at all, because you can always avoid those. Like, you can always change spaces by inline comments and things like that. So that's not a very good technique for avoiding this. I mean, you can always, there's always some kind of firewall technique that you can use on application level. Like, for sure, if you're sanitizing your parameters before, there's never an excuse to have something like union select something, or, I mean, very, very few excuses you can have. I mean, there's not many applications that are expecting such a parameter. So again, if you sanitize your queries, that's fine. The difficult part of it is because the nature of every web application accessing a database is so different. Having something between the application and the database that is generic, as we were mentioning before, that's really, really difficult. So it's up to the developer or the web application firewall to make some techniques here.
Have you applied this to a fair number of commercial databases to see whether or not they were, at this point, trying to sanitize and protect themselves?
Well, you have the proof of concept here for MySQL, all the versions of SQL Server, Oracle. So.
No, but have you tried this on commercial databases at this point in time, just to get some feel for how many of them are really vulnerable?
What do you mean by commercial databases?
Corporations, anybody?
Ah, so real life example. Yeah, of course, for sure. Yeah.
Tried that and you have some.
Yeah, of course, for sure.
I don't. Haven't you seen the chimeras? No? It's okay? It's okay? Thank you for your patience.
Thank you very much.
Thanks.